Hello friends, I am Balasaheb Nivdunge, Assistant Teacher of Std-10th Tafe. First welcome in the digital online test of Ahmednagar Jilla Marathha Vidya Prasarak Samaj, Ahmednagar. In 10th standard, Mathematics paper first. We have already learned 2 chapters. Now today we are going to study 3rd chapter, that is the arithmetic progression. Now in this arithmetic progression, let's study sequence, then arithmetic progression, nth term of an arithmetic progression, and sum of nth term of an arithmetic progression. Now see, this sequence arithmetic progression, this is the new topic for the students. Now let's take one by one. First consider sequence. Now here consider some arrangement of numbers. We know that we have already learned in a scholarship exam arrangement of numbers. Here also consider some arrangement of numbers 1, 3, 5, 7, 9 dash dash 0, 2, 4, 6, 8 dash dash 1, 4, 9, 16 dash 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 minus 5, minus 8, minus 11, minus 14 dash 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 8, 16, 32, 64, so on, 1 upon 1, 1 upon 2, 1 upon 3, 1 upon 4. Now see here, in each arrangement there is some relationship between any 2 consecutive numbers. That is, arrangement is written by some definite order and a definite rule. See, in the first arrangement 1, 3, 5, 7, 9. If we observe that difference between any 2 consecutive number is 2. So we guess the next numbers 11, 13 and so on. Here also difference between any 2 consecutive numbers is 2. Here 1, 4, 9, 16, these are the perfect squares. Here also difference between any 2 consecutive numbers is same. Here 16 is a double of 8, 32 is a double of 16, 64 is a double of 32 and so on. Here 1 upon 1, 1 upon 2, 1 upon 3, 1 upon 4 means denominator increases by 1. So what is the definition of sequence? So see here, sequence is a collection of numbers arranged in definite order according to some definite rule. So see here, in each arrangement there is a definite order and definite rule. Consider the pattern. So see here, pattern of number of circles. In first rectangle there is a 1 circle. In second rectangle there are 3 circles, 5 circles, 7 circles. So see here, in each rectangle circles exceeds by 2. 1 plus 2, 3, 3 plus 2, 5, 5 plus 3, 5 plus 2, 7. So in the next rectangle circles exceeds again 2, so the number of circles are 9. Next number of circles are 11, number of circles are 13, 15, 17 and so on. So see, to find a rule to obtain the next number from its preceding number, this helps us to write all the next numbers. Consider another pattern. In the first pattern there are 5 triangles, in the next there are 8 triangles, so number of triangles exceeds by 3. In the next there are 11 triangles, again number of triangles exceeds by 3. So if we guess in the next quadrilateral number of triangles are 14, next number of triangles are 17, number of triangles are 20, number of triangles are 23 and so on. So take a definition, terms of the sequence. Terms of the sequence. The individual numbers forming a sequence are called the terms of the sequence. Individual number, each number in the sequence is called a term of the sequence. The number in the first position is called the first term and is denoted by T1. T means term, suffix 1 denotes first term. So T1. The number in the second position is called second term and is denoted by T2. T2 suffix 2 denotes second and T denotes term. So second term. In general, the number in the nth position is called nth term and is denoted by Tn. And lastly, a sequence is usually denoted by in curly bracket Tn. In curly bracket Tn. Consider some sequences and show the position of the terms. So show the position of the terms by T1, T2, T3 and so on. So first sequence 9, 15, 21, 27. So term which occur in the first position, that is 9, which is the first term, that is T1. Second position T2. Third position T3 is equal to 21. In the next sequence, in the first position T1 is equal to 7. In the second position also T2 is equal to 7. In the third position there is also 7. So 7, 7, 7, 7. This is also sequence. This is called constant sequence. Constant sequence. Third, minus 2. T1 is equal to minus 2. T2 is equal to minus 6. T3 is equal to minus 10 and so on. Consider the second activity. Some sequences are given below. Check whether there is any rule among the terms. Find the similarity between two sequences. Now first of all, consider the first sequence 1, 4, 7, 10, 13. See here 1, 4, 7, 10, 13 and so on. If you observe that second term 4 exceeds by 3. So see here, if we add plus 3 in first term, we get second term. If we again add plus 3 in the second term, we get third term. So 1 plus 3, 4, 4 plus 3, 7, 7 plus 3, 10, 10 plus 3, 13 and so on. In the next, if we add 6 in the first term, we get 12. If we again add 6, we get 18. 18 plus 6, 24. So 6, 12, 18, 24. So the next term is obtained by adding 6 in the previous term. We get a rule. third sequence, if we add 0 in the first term 3, we get 3. If we add again 0 in the second term, we get third term 3, and so on. So 3, 3, 3, 3, and so on. This is also constant sequence. So see here, in the sequence first, second, third, next term is obtained by adding a particular number to the previous number. Each of these sequences is called an arithmetic progression. So see here, what is meant by arithmetic progression? If in the sequence the next term is obtained by adding a particular number to the previous number, then such sequences are called an arithmetic progression. Consider the fourth sequence, 4, 16, 64. See here, 16 is obtained by multiplying by 4 to the first term. So 4 into 4, 16. Third term is obtained by multiplying by 4 to the second term. So 16 into 4 is equal to 64. 64 into 4 is equal to 256, and so on. So see here, sequence 4 is not an arithmetic progression. In this sequence, the next term is obtained by multiplying the previous term by a particular number. This type of sequence is called a geometric progression. So fourth sequence is called a geometric progression. First three sequences are called an arithmetic progression. Now see here, 5, fifth sequence, -1, -1.5, -2, -2.5, and so on. So see here, next term is obtained by adding -0.5 to the first term -1. So -1 plus -0.5, we get -1.5. -1.5 plus -0.5, we get -2. So this is also an arithmetic progression. Now sixth sequence, 1 cube, 2 cube, 3 cube, 4 cube. See here, this is not a arithmetic progression and not a geometric progression. This is called a harmonic progression. So see here, arithmetic progression, geometric progression, and harmonic progression. These are the types of progressions. So see here, out of these three progressions in this chapter, we have studied only arithmetic progression. So let us study definition of arithmetic progression. So what is meant by arithmetic progression? A sequence in which the difference between any two consecutive terms is a fixed number or constant number is called arithmetic progression. See, difference between any two consecutive terms is a fixed number. It is called arithmetic progression. The fixed number is called the common difference of the arithmetic progression and is denoted by T. So what is the difference between any two consecutive terms? N plus 1th term minus nth term, or nth term minus n minus 1th term, or second term minus first term, or third term minus second term, or fourth term minus third term. This is the difference between any two consecutive terms. So this fixed number or constant number is called the common difference and is denoted by D. This value of D, that is the common difference, may be positive, may be negative, or 0. In an arithmetic progression, T2 minus T1, is equal to T3 minus T2 is equal to T4 minus T3 and so on is equal to D. What is D? D means common difference. So this is the difference between any two consecutive terms. In generally here Tn plus 1 minus Tn or Tn minus 1. Therefore, the next term T2 is obtained by adding common difference in the first term. So if we add D in the first term T1, we get T2. If we add D in the second term, we get T3. So T3 is equal to T2 plus D. Thus, the sequence Tn is an arithmetic progression if T2 minus T1 is equal to T3 minus T2 is equal to T4 minus T3 is equal to constant. So in an arithmetic progression, if first term is denoted by A and common difference D, in an arithmetic progression, if first term is denoted by A and common difference is D, then the sequence becomes T1 is equal to A. First term is denoted by A. T2 is equal to A plus D. Second term is obtained by adding common difference in the first term. So T1 plus D means A plus D. Third term A plus D plus D, we get A plus 2D. Fourth term A plus 2D plus D, we get A plus 3D. So if A is the first term and D is the common difference, then the sequence becomes A plus D, A plus 2D, A plus 3D and so on. Therefore, arithmetic progression having first term as A and common difference D is A plus D, A plus 2D, A plus 3D and so on. So let's remember a sequence, in sequence if difference Tn plus 1 minus Tn, this is the general difference. A particular difference is T2 minus T1, T3 minus T2, T4 minus T3 and so on. So in a sequence, if difference Tn plus 1 minus Tn is constant, then the sequence is called an arithmetic progression. In an arithmetic progression, the difference between two consecutive terms is constant and is denoted by D. Difference D can be positive, negative or zero. And remember that in an arithmetic progression, if the first term is A and common difference is D, then the terms in the sequence are A plus D, A plus 2D, A plus 3D and so on. So take some one or two solved examples from the textbook. First question is, which of the following sequences are arithmetic progression? If it is an arithmetic progression, find next two terms. Sequence is a 5, 12, 19, 26. We have to check whether this is a arithmetic progression or not. What is the definition of arithmetic progression? The difference between any two consecutive terms is constant. So let us check difference. See here, in this sequence 5, 12, 19, 26 and so on. First term is T1 is equal to 5. Second term is 12. Third term is 19 and fourth term is 26. So take a difference T2 minus T1, 12 minus 5 is equal to 7. T3 minus T2, 19 minus 12 is equal to 7. If we take T4 minus T3, we get 26 minus 19 is also 7. So difference between any two consecutive term is 7. So constant. So here first term is A and common difference is constant, that is D is equal to 7. So this is an arithmetic progression. So next two terms in this arithmetic progression are Fourth term 26. So next term is 26 plus common difference 7. So 26 plus 7 is equal to 33, and 33 plus 7 is equal to 40. So next two terms in given arithmetic progression are 33 and 40. Take next solved example. Question is, the first term is A and common difference D are given. Find first four terms of arithmetic progression. So here A is equal to minus 3 and common difference D is equal to 4. We have to find the first four terms of arithmetic progression. So given A is equal to minus 3, D is equal to 4. So first term T1 is equal to A is equal to minus 3 is given. So T1 is equal to minus 3. If we add this common difference D in the first term, we get next term. So T2 is equal to T1 plus D. So minus 3 plus 4, which is equal to 1. So second term T2 is equal to 1. If we add again D in the next term, in the second term T2, we get T3 is equal to T2 plus D. 1 plus 4 is equal to 5. If we again add D is equal to 4 in the third term, we get fourth term. So T4 is equal to T3 plus D. So 5 plus 4 is equal to 9. So we get T1 is equal to minus 3, T2 is equal to 1, T3 is equal to 5, T4 is equal to 9. So the arithmetic progression is minus 3, 1, 5, 9 and so on. So in this way, today's lecture we have studied what is the sequence, terms of sequence, arithmetic progression, and first term, second term, third term, fourth term, common difference and so on. So we can stop here. Thank you. विद्यार्थी मित्रांनो, या ठिकाणी आपणास जर हा व्हिडिओ आवडला असेल तर आपण लाईक करा, शेअर करा, कमेंट करा, बेल आयकॉन दाबा आणि प्रोत्साहन द्या. धन्यवाद.